What actually goes on inside the mind of an AI agent? While a standard chatbot simply matches patterns and predicts the next word, an agent does something much more profound. It reasons. It breaks down complex problems, consults external tools, and iterates until it finds the best solution. If you're ready to master the next generation of AI, make sure to follow along and subscribe. Welcome to episode 3, How AI Agents Reason and Make Decisions. At its core, every AI agent operates in continuous loop. It starts by perceiving its environment. That could be your latest prompt, a new row in a database, or the output from a previous action. Then comes the critical stage, reasoning. This is where the agent interprets that data and decides what it actually means. Next, it plans a sequence of steps to reach its goal. And finally, it acts. Maybe it searches the web, writes code, or updates a project board. Then it observes the result and the loop starts all over again. But here's the secret. While traditional software follows rigid if-then rules, an AI agent's reasoning is probabilistic. It doesn't follow a fixed path. It weighs options and generates the next step based on context. That's its greatest strength, but as we'll see, it's also its biggest challenge. To handle this complexity, researchers have developed several core reasoning strategies. Let's look at the 5 most important ones you'll encounter. First, react. Reasoning plus acting. This is the bread and butter of modern agents, where the agent thinks out loud, takes an action, observes the result, and repeats. Second, chain of thought. Here the agent is forced to show its work, breaking a hard problem into simple, logical substeps. Third, self-ask. This is incredibly powerful for complex research, where the agent literally asks itself follow-up questions to bridge knowledge gaps. Fourth, tree of thoughts. Instead of one linear path, the agent explores multiple reasoning branches simultaneously, pruning the ones that don't look promising. And fifth, reflection, where the agent generates an answer, then steps back to critique and refine its own work. These aren't just academic concepts, they are the building blocks of production grade AI. In this video, we will look into React and self-ask. Let's first see React in action. Imagine we ask an agent, who directed the movie that won the Oscar for Best Picture in 2024? The agent first thinks, I need to find out which movie won Best Picture in 2024. It takes an action, searching the web for the winner. It observes the result. Oppenheimer won the Academy Award for Best Picture. Now it updates its plan. The winner is Oppenheimer. Now I need to identify the director. It performs another search for the director. Observation. Christopher Nolan is the director. Finally, it synthesizes the full answer. Notice how the reasoning isn't a straight line. It's a dynamic conversation between the agent and its tools. Then there is self-ask, a strategy specifically designed for multi-hop reasoning. Imagine asking, was the creator of Star Wars born in the same state as the creator of Apple? The agent doesn't guess. It asks itself, who created Star Wars? Answer, George Lucas. Next, who created Apple? Answer, Steve Jobs and Steve Wozniak. And finally, were they born in the same state? Answer, yes. Both Lucas and Jobs are from California. By breaking the complex question into smaller, verifiable chunks, the agent achieves much higher accuracy than a standard LLM. But how do you actually implement this? Frameworks like LangChain handle the loops under the hood. We start by defining our tools, like a search engine or a calculator. Then we construct the agent by combining our LLM with those tools and a specialized prompt. The real magic happens here, the agent executor. This is the component that manages the internal reasoning loop, deciding when to stop or continue. Finally, we simply invoke the executor with our question. In the trace, you can see how LangChain manages the entire flow. It's the same pattern we visualized earlier, now running as efficient high-level code. Self-ask implementation follows a similar high-level pattern. Again, the complexity of managing sub-questions and context is abstracted away by the framework. We use a specialized self-ask agent constructor that knows how to handle multi-hop reasoning. The agent executor once again steps in, this time managing a linear cascade of sub-questions rather than a simple circular loop. When we invoke it, the framework handles the recursive logic of asking, answering, and aggregating until the final result is ready. In the trace, you can see this structured discovery process. LangChain makes implementing even the most complex reasoning strategies remarkably clean. Knowing the strategies is only half the battle. To build agents that actually work in production, you need to employ these 5 engineering techniques. Number 1, structured prompting. Don't just ask a question, give the agent a scaffold like thought, action, observation. Number 2, few short examples. As we saw, showing the model a few worked examples of the reasoning you expect is the single most effective way to improve performance. Number 3, tool grounding. Give your agent real tools, a calculator, a database, a search engine. When it can verify facts instead of guessing, hallucinations drop by 90%. Number 4, memory management. Keep the context window lean. Use summarization or vector search to ensure the agent only sees what's relevant right now. And number 5, guardrails. Always add a validation layer to check the agent's output before it reaches the user. Think of these as the 5 pillars of reliable reasoning. So, which strategy should you use? It all comes down to your specific use case. If you are building a simple customer support bot where speed is everything, basic chain of thought is usually enough. But if you are building an autonomous researcher where accuracy is non-negotiable and you have access to external tools, you'll want to combine React with reflection. The key is to match the complexity of the reasoning strategy to the complexity of the task. Too much reasoning can be slow and expensive. Too little can be dangerous. Use this advice as a starting point to find the right balance for your next project. Before we wrap up, let's talk about the tools that make all of this possible. There are 3 major frameworks you should know. First, LangGraph. This is the gold standard for building stateful cyclic workflows. It gives you absolute control over every node and edge in your reasoning graph. Second, CrewAI. This is designed for multi-agent collaboration, where each agent can have its own reasoning strategy and its own specific role. And third, Microsoft's AutoGen, which excels at complex conversational agent interactions. My recommendation, if you're just starting out, start with LangGraph for single agent loops or CrewAI if you want to see the power of multiple agents working together. Reasoning is the beating heart of an AI agent. It's what transforms a simple prompt response chatbot into a true autonomous partner that can solve complex problems. Today, we covered the foundational strategies like React and self-ask and the engineering techniques needed to make them reliable in production. In the next episode, we are going even further. We'll explore multi-agent systems. What happens when you have multiple AI agents reasoning together, debating, and dividing complex tasks among themselves? If you found this helpful, hit that like button and subscribe so you don't miss the next one. I'll see you in the next episode of Agentic AI Simplified.